Alright, let's go ahead and review some homework problems from last night. And so the first question here is asking you to find the area under the curve of this function here, rad x plus 1 on 0 to 3. And so the first thing I'm going to do is I'm going to go ahead and graph this thing. And the x plus 1 means that the graph is being shifted to the left by 1, and again, it's just a rough sketch. And realistically, we just got to know how we're going to space this thing out. So remember, in the homework from the book, it says you let n equal 10, but we wanted to modify the instructions so that n equals 6. And the way we get the width of each shape that's going to happen, I'm going to be moving from 0 to 3 with a width of 6 with 6 shapes every single time, which means they're all going to need to be evenly spaced. Well, how do I get that space? Well, I get that space by saying, remember this b minus a over n formula, which is going to be, in this case, 3 minus 0 over 6, which is going to be 1/2, which means from 0, every space is 1/2 long. So in other words, I'm going from 0 to 3, but actually I could consider this 0 to 6 over 2, right? So I got 1, 2, 3, 4, 5, 6 over 2, because that's going to be 3, right? And everything is going to be 1/2 long. And so you see how that effect kind of happens here, where I have one shape, two shapes, 3, 4, 5, and whoops, I forgot about this guy, 6. And so yeah, we have 6 shapes. They're each a half long. I think we're ready to rock and roll. So a lot of this is going to be, setting it up. The hardest thing to do is finding the spacing, but as long as you follow this b minus a over n, you'll pretty much be able to get all of them. And so let's go and take a look at the left-hand rule, right-hand rule, and midpoint for this problem here. So if I look at the left hand, and actually before I do that, let me pause real quick. Alright, sorry, I had to copy that image because we're going to be graphing this multiple times. Okay, so left-handed rule is going to be, well, if I'm doing a left-handed rectangle rule, well, I'm going to be taking the areas of each rectangle, and the area of a rectangle is base times height. So what I'm going to do is I'm going to go and switch to ketchup here. And if you notice, each height, or each width here, each base is the same length. They're each going to be 1/2 long, and I just realized I put a 6 right there. I don't know why that was. That should actually be a 2. So mustard gets covered by ketchup. That's a 2. And so what I'm going to do is, if you notice how each length is a half long, that means that I can factor out that half. Again, what did I do? Well, I factored out all the bases which belong to us. If you understand that reference, good for you. And what I'm going to do is I'm going to go and add up all the heights together. Now remember, the heights are taken from the left side of the rectangle. So my first rectangle happens right here, because I'm going from 0 to 3, right? And so that's my first rectangle, yeah? And so how did I get that height? Well, I got that height from this portion of the rectangle, which is f of 0. Now if I look at the second rectangle, which is going to be this guy, well, again, I'm going to pull that from the left side of the rectangle. That's how I get the height. So that's going to be f of 1/2. Now again, it's always going to be base times height, right? So I got base times height, base times height. So again, I just factored out the 1/2 because I factored out all the bases. And so I keep going down the chain here, right? And I think you guys can kind of see where this is going, where I end up with that effect happening here. So I'm going to go f of 2/2 plus f of 3/2 plus f of 4/2 plus f of 5/2. And again, I'm going to stop at 5/2 because 6/2 is really the right side of a rectangle. And I don't need that because I'm working a left-handed rule. So hopefully you guys will be able to keep up with that. Let's go ahead and take a look at what this does on the Inspire calculator. So let's go ahead and load this thing up. Alright, so now we have our calculator up and running. So what I'm going to do is I'm going to hit this button that has it looks like the calculator running away from somebody. It's underneath the escape button here. Takes me to the graph, and I'm going to go and enter in the function. So what I get is control square root, and I'm going to type in an x plus 1. That's our function. I enter it in. Now, I may not need this graph yet, but what it does is if you hit the tab button, it stores that f1, right? And we're going to need that in a few minutes because I'm going to go ahead and come here, and let's look at the function again. It's 1/2 times all of this from f of 0 to f of 5 halves. So let's see how that looks. I'm going to go ahead and come back to this. So I'm going to say 1/2. Now, how do I do 1/2 without using parentheses? Well, if you look at this button here that says times, I'm going to go ahead and use the button that's right above that. It's this button that looks like a Moai out of Easter Island or from Gradius 3, whatever, wherever it is you were first exposed to that. Type in 1/2. I'm going to hit the right button to create a new section. I'm going to hit parentheses, and now I'm going to start typing in my stuff. Remember, the area of a rectangle is going to be base times height. So I'm going to add up all those heights. So I'm going to hit F1, and I'm going to open the parentheses and put 0, because that's where the first height was called from. Next, I'm going to hit plus F1, hit parentheses of 1/2, plus F1, parentheses 2 halves, plus F1, all the way down the chain is where we're going to go. So once I get to the 5 halves mark, I'm going to go ahead and hit the control button, and I'm going to go ahead and hit enter, and hopefully we get the right answer. That is correct. It's the 4.411 numbers. I'm going to write that down. 4.411. Okay, so that's left-handed rule. All right. I'm going to actually try and rely on you guys to figure out right hand and midpoint. Okay, just to keep this video at a decent enough length. I'm going to go and move on to another problem here, and that way I can move forward with showing you guys how to do some stranger intervals. I'll be back in a flash. Alright, so this one here, a little bit stranger because we're not starting at 0 anymore. So usually when the integrals start at 0, it makes it a lot easier, but this one starts at 1. So again, it doesn't really change a whole lot except for the fact that everything's being shifted over to the right by a little bit. So it doesn't change the fact that I'm still having 6 shapes underneath. But in order to find the width of each one, I'm going to go and do the b minus a over n, which is going to be 4 minus 1 over, looks like 6. Well, that's 3 over 6, so again, 1/2 is the length of each shape. Alright, so let's see how this turns out. Well, since I'm going from 1 to 4, I'm going to start right here, actually. And each space is 1 piece long, so ultimately, when I end at 4, hopefully it makes sense, or since I began at 1, hopefully it makes sense that my first shape, or my first point, is 2 over 2. And each one is going to be 1/2 long until I get to 8 over 2, which is 4. So that's 2 over 2, 3 over 2, 4 over 2, 5 over 2, 6 over 2, 7 over 2, and last but not least, 8 over 2. So do we have indeed 6 shapes? I'm starting at here. I got 1, 2, 3, 4, 5, what do you know, 6. I love how that works out. Okay, so now I'm going to go ahead and use right-hand rule on this thing. All right, we didn't see that in the last example. So right-hand rule. All right, now before I do that, I'm going to go ahead and copy this because I have a feeling that I may need it. It is possible that I will need it at some point. And so let's go ahead and copy you. Thank you. Okay, cool. So now, right-hand rule. So that means that all of my heights are going to be pulled from the right side of this rectangle now. So now my first place is going to be right here at 3 over 2. And then my next place will be 4 over 2. And then 5 over 2. And then 6 over 2. 7 over 2. Now notice I'm actually going to use the 8 over 2 this time because it's on the right side. So what I have is 1/2. That's my width, right? My width didn't change even though I'm doing right-hand rule. It's going to be F of 2 over 2 plus f of 3 over 2 plus f of 4 over 2 plus f of 5 over 2 plus f of 6 over 2 plus f of 7 over 2 plus f of, in this case, we are going to include 8 over 2. Unlike the last one, we just didn't include f of, darn it. We just didn't include this guy. So, the right side, right side, right side, right side, right side, right side. So, whoops, don't do that. That is wrong. Okay? So, make sure we don't do that. So from here, let's go and just punch this thing into the Inspire. I'll let you guys go ahead and do that. Again, for time purposes, I'll go ahead and keep that short. I want to pause real quick. I'm going to go to Trapezoid, and then after that, that'll be it. Alright guys, let's talk about Trapezoid rule. I switched over to Relish as my color this time. Now with Trapezoid, the area of a trapezoid is going to be 1/2 height, base 1 plus base 2. Now remember, the height is determined this way, right? If we turn our head sideways, we end up getting that height of the trapezoid. So what I'm going to do is I'm going to go and go 1/2, and all of my heights can be factored out because what I have is a consistent height of 1/2. And now I'm going to go ahead and do base 1 plus base 2. So that's going to be f of 2/2 plus f of 3/2, right? Now, I should have left myself a little bit of space there because hopefully you're going to see what's going to happen. In the next heat, I'm going to go ahead and go, remember that's 1/2 height and then base 1 plus base 2. Now I'm going to go and add base 1 plus base 2. This is the second trapezoid, right? And the second trapezoid uses 3/2 as the first base and 4/2 as the second base. Now, if you look at 3/2, notice how it was used as the latter base of the first, but it's also the first base of the second, which means there's 2 of those f of 3/2. I think you guys are going to start to see a pattern here, where the 4/2 is going to be used twice, the 5/2 is going to be used twice, once as the latter end, once as the former end, yeah? And then 6/2 will be used twice, and 7/2, hang on, 6/2 will be used twice, and then 7/2 will be used twice as well. Again, once as the ladder of this trapezoid, and then the leader of the next trapezoid. So, whoops, that's not a trapezoid, that's a triangle. Like that, right? So, 7 over 2 is going to be used twice, but f of 8 over 2 will only be used one time. Okay? So that's a quick review of trapezoid rule. Hopefully you guys understand that. If not, I'll be back tomorrow with some more questions. See ya.